Thank you very much, David, for coming along today. David has worked in academia VR research for over 20 years and is currently a senior research fellow in the Virtual Environments and Computer Graphics group at University College London. He collaborates on a wide range of research and experimental work with a particular interest in how knowledge of human perceptual mechanisms can be exploited to overcome technical limitations of VR systems. This is manifested by studies spanning psychophysics, navigation control, interaction, haptics, and the social response within the virtual environment systems. And he has published widely across these themes. David also runs UCL immersive VR lab spaces, maintaining and overseeing four-wall cave hybrid setup, mock-up systems, haptics and telerobotics setups, and ever-growing collection of VR and AR headsets. So it's a pleasure to have David here. I know David for some time, and he helped me a lot when I was doing my doctorate. So it's a real pleasure to have David here. With no further ado, welcome, David.
Okay, thank you, Abel, and thank you for inviting me to talk here at DCIO. I think this is a great collection of people and work you've brought together, and very happy to contribute. As Abel has introduced me, I work with the Virtual Environments and Computer Graphics group at UCL, and I'm in charge of the physical lab spaces. Abel mentioned the cave. I will talk a little bit about that during this talk, because this was kind of my introduction to architecture and working with the Bartlett School 20 years ago. So as someone who comes very much from the technical side of this community, I initially had some doubts as to what aspects of my work would connect best with this conference. So before I get to the main focus of my talk, I'm going to take a little step back to contextualize the work that I do and how I hope it maps onto the interests of the DCIO community. So while a lot of our work is very technical in nature, we have always spanned a wide range of activities, from low-level computer graphics algorithms right through to higher level human factors studies. And our work has always been out of necessity interdisciplinary. There are many reasons for this. And one of these is that virtual reality has always really been an idea that has been trying to prove itself. So since the first demos of the 1960s, there have been many, many cycles of hype and disappointment. I'm sure we've seen these charts for many industries, but it applies to virtual reality possibly more than any other. So for the VR community, it's always been part of our role to manage expectations and provide realistic goals to our potential collaborators. So demonstrating the utility of the technology in various domains, even when the technology itself is confined to research labs, has helped not only in practical development of the technology, but also in the generation of knowledge in many other academic domains. So for our group, some of our most successful work has been done in collaboration with architects, social psychologists, clinicians, artists, neuroscientists, many other domains that I'm not mentioning here. And my current projects also sit in very different spaces. So on one hand, we have the Graphics Pipelines project, which is designing and developing algorithms and systems for the next generation of low latency displays. And on the other hand, I'm working on an EU project with a consortium of clinicians, designers, mechanical engineers, and experts in assistive technologies, developing interfaces to increase access to VR technologies. So this provides some context to the type of work that I engage in. So I'm now going to move more to the main focus of my talk. Now, the title of my talk, Design Interfaces with VR, the ambiguity is intentional. The dual readings I intended are firstly the theme of how we can design interfaces for virtual reality, and secondly, the idea of design interfaces as an abstraction of how we perform design processes within the context of VR. I actually spotted, looking at my slides earlier this morning, that there is a third more imperative interpretation that is unintended. Okay, so what I hope to explore are some of the issues with utilization and development of virtual reality systems and methods. In other words, with the VR hardware available now and in the near future, what types of systems can we design? And what types of systems should we design? Now, to a large extent, this is a question that is beyond the scope of my experience. So I'm neither an architect nor a designer, well, not in any traditional sense of these terms. I may have reevaluated that on the basis of the previous speaker. What I bring to this question, though, is my accumulated expertise in VR systems and from the various collaborations I've worked on. And what I'm hoping to get to is how to galvanize the skills that are required, not just to replicate current practice with a VR interface tacked on, because we've all seen that, but to innovate and take full advantage of the capacities of immersive technologies. And the germ of this idea really lies in the initial collaborations that we had with the Bartlett School of Architecture 20 years ago, after we commissioned a VR projection theatre, which Abel referred to. This is the Cave. And this is a project that I was brought into on the back of previous work on embryonic VR systems from a perceptual perspective. So this is a project at Reading University where I was building VR and graphic systems to explore how human perceptual mechanisms facilitate our movement through the world. So lots of work with active interpretation of optic flow fields, that sort of thing. Now, the Cave, this represented a completely different type of challenge. This is a much bigger and more complex system, and it relied on making non-standard hardware work together in novel ways. So this is what the Cave looks like to an onlooker outside. The person in the Cave is having their head position and orientation tracked. So the image generated are for their point of view. So what we see in this image is a sort of geometric distortion at the edges and corners, is to them perspective correct view of the simulated world. The facility itself, it's a 3 meter by 3 meter room with external projections on the 3 walls and the floor. So in this model view from above, you can see the whole facility with the projectors aimed at mirrors around the cave itself. And here we have in the left-hand image, this is a view from outside the cave, showing how we fold the projection with mirrors to reduce the overall footprint of the facility. And the right-hand image shows the corresponding image produced inside the cave. So the fourth wall, this is left open. It optionally could be there, but we leave it open. This is so that onlookers can see what is going on, or experimenters can monitor participants, and it facilitates communication between the person in the cave and the people standing outside. Now, with the walls being back projected, no shadows are cast, but the floor, out of necessity, is projected from above. So you can see a shadow on the floor, but this is typically not visible to the tracked user. And the only equipment that the user has to wear is a pair of liquid crystal shutter glasses. And this means that the user is not isolated from the real world, can communicate with their colleagues in a more natural way than is afforded by head-mount display devices. So back in 2000, what was exciting about the system was that it offered a real step change in VR capabilities from the headset systems of the 1990s. And for reference, this is what a late 1990s head-mounted display looked like. They were usable as research tools and rudimentary design tools, but the image quality was poor. And as you can see from the image, you had to have quite strong neck muscles to wear this for any length of time. So the Cave was the state of the art for VR 20 years ago, and it was also a collaborative effort between UCL Computer Science and the Bartlett School, with a view to using the system for teaching, research, and architectural visualization. Sorry. However, the realization of this idea was not initially straightforward. Many of the architectural models brought to us couldn't easily be adapted to this new technology. And the issue was that these models were designed for single viewpoint renderings and weren't limited by real-time considerations. So they could be processed on a standard desktop computer to produce beautiful renderings, but each rendering might take 20 minutes to produce. But for VR, we need real-time frame rates, and the models were just simply too large and detailed for this. We had a system with the most powerful graphics computer available, but despite this vast processing power, many of the imported architectural models would just stutter along at 1 to 2 frames a second, and the experience was somewhat less than interactive. So consequently, we would then spend many hours stripping out detail from these models until we could achieve interactive frame rates. But this was to the detriment of the visual quality of the models. The types of things we removed were often the most ornate aspects, elements that are hard to model with just a few polygons. So away went rows of trees from streets and parks, or intricately modeled interior design. And most importantly, we would usually end up removing most of the lights, since these had a linear cost of processing overheads. Fast forwarding to today, many of these tensions between designs for single viewpoint renderings and designs for real-time rendering are much better understood, better catered for by software. And of course, advances in graphics hardware have vastly improved this situation. So today, the cave is driven by even more powerful graphics hardware than before, but this is now all accommodated in a single desktop PC. And in parallel to this, VR headset technology has undergone a revolution in quality and cost. Technology borrowed from the mobile device industry has driven a revolution that has brought good quality commodity headsets down to consumer price levels. So now that we have affordable devices available, what are the factors that still hinder progress? So up to now, I've mostly described the technological landscape, and this is really my comfort zone. But to examine slow uptake of VR technology, we need to look beyond the tech. The design of useful VR tools should come as much from the designers who want to use these systems as from the engineers who create that possibility. In the context of architectural design, the requirements of VR interfaces that allow architects and designers to do useful work, and not just the walkthrough type simulations that are most easily facilitated. So this requires some insight into the design process that both assists the intuitive performance of a range of typical tasks and doesn't stifle the ability to take novel and innovative approaches. So at last year's DCIO conference, Robert Aish gave a keynote where he discussed the technological transitions that have taken place in architectural practice over recent decades. And firstly, he described the transition from 2D drafting to BIM, and then laterally to higher level topology representations. And while advocating for the advantages brought in by the new methods of BIM and the technologies that support them, he also highlighted a downside to these methods, in that they could be seen as constraining possibilities and channeling design decisions according to the implicit constraints of BIM. And it was these processes he described that caught my attention. So virtual reality systems are not modeling tools in and of themselves. Rather, they provide a new means for an architect or designer to interact with their design. How we design these interfaces is what is going to be critical to their success as tools. Even with a perfect VR display, how should we interact with it? It's necessary, but it's not sufficient to understand the types of activities supported by, for example, BIM or topology modeling. But designing interfaces that attempt only to translate existing software methods to the VR domain is just taking the path of least resistance. So what is it about VR that is useful to architectural practice? One of the benefits over other interfaces is the ability to experience a space, whether this space is a house, railway station, whole city. Architects are trained to represent and interpret space through a variety of design media, sketches, engineering drawings, CAD models, and so on. VR adds the ability to directly experience these spaces dynamically. And what distinguishes VR from all these other media is the experience of space that it affords. This is often referred to as our sense of presence. So what I mean by this is the highly subjective sense of being there in a simulated environment. And anybody who's tried out virtual reality may or may not have experienced this, or will in some applications and not another. And this is critical for many VR applications, especially so for architectural visualization. We need to be confident that the sense of place that we experience in VR is comparable to what we would experience in a real world space. And this is associated with the degree of immersion afforded by the VR system. This is a more objective measure of simulation quality. So for example, wider field of view means more immersive, lower latency tracking, better tracking all means more immersive. Additionally, as a means of communication with clients or non-experts, a client's ability to interpret abstract representations is most likely limited, and VR allows the direct communication of ideas and can limit the scope for costly misunderstandings. This is not to say it's a perfect solution. Even with the most powerful graphics processors and the most capable tracking and display systems, there are some fundamental challenges. First, and most importantly, is the problem of navigation in VR. So to experience a design, you need to be able to move through it and explore it from multiple perspectives. But navigation through space in VR can give rise to undesirable side effects of visual discomfort, dizziness, or nausea. This is commonly referred to as simulator sickness. It's principally caused by the disconnect between our visual and vestibular senses when we move virtually. That is, when we use a controller or a joystick to move rather than actually walking through the space. In other words, our eyes see that we're moving, but our bodies do not receive the corresponding vestibular signals that it is moving. Some VR simulations allow teleport navigation. This circumvents the visual-vestibular conflict problem, but it reduces our ability to know where we are in the world. So our path integration relies on sensory inputs caused by our movements. So if we teleport, we remove the conflicting cues that cause simulator sickness, but we also reduce our capacity to know where we are. It also disrupts our experience of moving through a space, which is possibly a critical aspect of any evaluation. Of course, you can also mitigate this by just having a large tracked area that allows you to move around, but this depends on having the requisite space to do this. I'm going to skip through this slide and move straight on to collaborative VR because I'm conscious of time. The slide on headset reluctance was really to get across the idea that people just don't like wearing headsets very often and consequently won't wear them for very long because it isolates them from the community around them. So you will have this very nice VR demo and somebody will wear a headset for 30 seconds and then take it off to speak to people, possibly not put it back on. Collaborative VR is something I want to focus on more though. And this has been the preserve of research labs for decades. So there were early research tools like Dive in the early 1990s. And in the age of commodity VR, collaborative VR has attracted increasing interest. Since 2015, there's been a proliferation of social VR platforms and applications. And during the COVID lockdowns of the past 18 months, our VR research group at UCL has, like almost everyone, spent many hundreds of hours in online meetings and conferences. But we frequently abandoned these forums in favor of exploring the range of collaborative VR apps on offer. These typically allow groups to meet in a private space that can be selected from an overwhelming variety of settings. So this provides some advantage over traditional video conferencing tools. It can work with consumer level devices, so costs are low and infrastructure is portable. Participants can see each other, mitigating the problems of social isolation and headset reluctance. And on top of this, team members can be in a natural spatial arrangement, standing in a circle, dividing into groups, sitting around a coffee table. And this allows a more naturalistic interaction. The conversational cues that are absent from a video conference are reintroduced. nods, gestures, turning towards others provide powerful social cues that we intuitively respond to. And it's the absence of these that sometimes leads to the jarring disruption of conversational flow in video conferences. So for the moment, at least, collaborative VR avoids more, but not all of the obstacles that stand in the way of productive design activities. So what I've tried to present here are what I think are the key characteristics of modern VR systems that can be exploited by designers. VR technologies have developed in many directions over the past few years, and while some fundamental issues remain to be resolved, many technological advances have been very significant. In particular, collaborative VR systems are now viable and provide a means to circumvent many of the problems of single user systems. How these map onto teamwork and design activities is domain specific, so systems design has to be led by domain experts. Finally, and crucially, navigating the possibilities afforded by these technologies is key to designing interfaces that don't constrain and frustrate users. And that concludes my talk. Thank you for your attention.
Thank you very much, David. I'm aware of the time, but I do have a very tempting question, a very silly question. Have you seen Blade Runner 2049?
I have not seen it yet, no.
So yeah, the main character, so Kay, the protagonist Kay, he has this holographic girlfriend called Joy. And it's basically an equipment they have in the ceiling of his living room, and then he sees this person who makes him company as a solution for the loneliness of being a clone, or a replicant. How close are we to something like this, where VR is just part of our ambient, our domestic ambient?
So this really speaks to the former of the projects I described. So we're not just looking at low latency systems, we are looking at holographic displays as well. But these are still, these are still very experimental systems, and the equipment we're assembling to try these things out is still very, very expensive. So yes, we're still a bit away from that. I mean, in many respects, the promise of, I did think of talking more about augmented reality, but it's just too hard to get everything into a 20-minute talk. The promise of that removes many of the obstacles that we have with current systems, but the technology is just not there yet. So it's just not viable. And holographic displays, again, they will arrive, but there are all sorts of problems. So unfortunately, I have not seen Blade Runner 2049 yet. I don't have a sense of how.
Yeah, I'm asking that because when I was trying the headsets upstairs in computer science, we experienced that thing, and then when you take it off, when you go back to the real world, it's quite disappointing. The VR is so fascinating and so fantastic that it feels almost that going back to reality is a little bit downgrading your experience of the world. So it's quite odd. So that's why it's a silly question, but I was curious about it. We have some questions here from Greg from Bentley Systems asking if you have tried Outspace VR, and what's your take on it?
So I've tried Outspace VR. That was one of the early ones that we tested out. It was kind of designed more for a business format for doing presentations. One of the problems I've seen with these, and this includes Outspace VR and others, is that you could go into these collaborative VR spaces and you would be put in something akin to a meeting room, very nice meeting room, and you could do things like have a PowerPoint presentation. It's like, well, do we want to go all the way into a virtual space where we can do anything, we can do what we like? We don't want to do a PowerPoint presentation. So this is what I mean. So, we have these affordances there, but people haven't quite got their head around what we should do in them. So I think I attended a conference in Outspace VR, and for the large part, it worked quite well. The things that didn't work were things that were just technical things that went wrong. But there are a number of collaborative interfaces out there. I should mention that we as a research group are building our own one. so that we can have an open source tool that anybody can use. And we're using it for doing experiments in VR. So we will be releasing that very shortly.
Great. Thank you again, David. And hopefully in the future, when we can go back to the physical world and run our conferences face to face, we can organize to experience the hardware firsthand.